So the standard form, the standard form of a quadratic equation is ax squared plus bx plus c equals 0. And of course, the a cannot equal to 0 if it's going to be a quadratic. So when we're solving, we want to be looking for values that make the equation a true statement when you plug it into the equation. So I just want to start off with the 0 property. If I have a times b, if I have a product, and that product is equal to 0, what must be true? Yeah, a equals 0 or b equals 0. And we can check that really quick, of course. We can have 0 times b, and that's equal to 0 because of the 0 property. Or we can have a times 0, if b is equal to 0, equals 0. So they both result in a true statement when plugged in. So what does this have to do with solving quadratics? Well, we just learned how to factor quadratics. When you're factoring, you put quadratics in a product. You're making them into a product, so then you can take each product and set it equal to 0. I want to solve x minus 3 times x plus 2. That's a quadratic that's been factored. I can set, this is kind of like my a, and this is kind of like my b. So basically, I can set x minus 3 equal to 0 or x plus 2 equal to 0. So I can set each of those products equal to 0 and then solve each one. What we've done is we've just reduced it to a linear. So we isolate the variable. First, you have to put in standard form. That means 0 on one side. Second, we factor completely. And third, we're going to set each, I'm going to use the word variable factor, to 0 and solve. And check. This is optional. There's going to be many times when this last step is not optional. So for example, so here, when we go through our steps of factoring, we see there's a 2 in common in every single term. And if we factor that out, we do see it's much easier to factor. So now I can factor this trinomial into 2 binomials. That 2 still comes down. X. Now you can try 2 and 3, but that's not going to be 7. So we will be using 6 and 1. 2 negatives will make a positive, and then you get minus 6x minus x, which is minus 7x. We do check our middle term, so we're good. So now, this is what I meant by set our variable factors to 0 and solve. The idea here is if we have a degree of 2, the highest power is 2, you should have 2 solutions unless they're repeated roots. So, since it's 2, we have 2 variable factors. We set those equal to 0 and solve those, and we can ignore the 2. If it bothers you, look what happens. This is why we can ignore it, because you can divide each side, both sides by 2, and then it gets disappeared. So finishing this, we get x equals 6 and x equals 1, and we can definitely check our original. The only reason to check would be to make sure you factored it correctly. Those 2 do add up to be 84, so you get 0 equals 0. The second one's easy to check. It works. We're going to solve this new equation, and it's not in standard form, so first we need to get 0 on one side. I'll subtract the 5x squared on both sides, but I want it to be in descending order. So 3x to the third minus 5x squared minus 2x is equal to 0. Now we want to factor completely. Notice how we have an x in common now. So I'm going to factor an x out. And now we have this quadratic that we can, it's a quadratic, but it's also trinomial, which can factor into two binomials. So 3x times x is 3x squared. 2 and 1, we can try 2 and 1. And this is 2x, and maybe we want to guess a plus and a minus. Plus, minus, minus 3x. That's a minus x. That's not going to work. So now I'll swap that 1 and the 2. Put the 1 there, put the 2 here, and make that minus and that plus. That's plus x minus 6x. Yep, it works. So we've checked all the terms. And then now we have, again, remember degree 3. So we have 3 variable factors. None of them are repeated. So we set each of those equal to 0. And then we solve each of those. Well, there's 0 as a 1 answer. Here I have a little bit of work to do. Subtract the 1, divide by 3. And add that 2 to the other side, and we have 3 answers. That's it. You just got to know how to factor. Thanks for watching.